Hey, this is Mrs. Williams. I just thought I'd go over this question quickly here and just demonstrate how this works. So the question says the headlights of a car are mounted at a height of 2.5 feet. So that's from the ground up to where the headlights are on the car. If the light beam drops 1 inch, so you can see my hints are that these are vertical, so the 1 inch would be an up or a down amount. It would be down, it's dropping 1 inch per every 36 feet that the light shines out. How far ahead in the road will the headlights illuminate? And so we're looking for the projection of the light from the car. So that's the key to this proportion. This is a proportion question, but it's a little tricky. You want to just think of what amounts are vertical, what amounts are horizontal, and that will help you get everything placed correctly. So the 1 inch is the amount that the light will drop for the projection out horizontally for 36 feet. 2.5 feet is how much, what the height of the headlights are up for, and we want to know how far would that project out. Now, to solve this, the key is getting everything in the right unit. So we see inches here and feet here. Feet here and feet here, those are good to go. They're matching, but we want to, I would say let's convert this to feet just because everything else is in feet. So we can think of this, let me change my color here. We could think of this as 1/12 of a foot. So 1 inch would be the same as 1/12 of a foot. And then we should be able to set up our proportion. So we can say this 1/12 of a foot, since it's a vertical amount on that triangle, would match with the 2.5 feet on that same side. So we're just matching sides of the triangles. We know these triangles will be similar. So 1/12 feet, and I know this is not looking like a proportion yet, but it will. Okay, and then we can say 36 feet and x feet. Those are on the same side of the triangle, so those will match. And so I'm going to put that underneath. The key to proportions is matching it all up. So the reason that I'm putting each of these in the denominator because the sides match on the triangles, and then I'm lining these up in a fraction because they come from the same triangle. And then these are lined up because they come from the same triangle. So now, if we cross multiply, that would be how we'd want to solve this problem. So we can say 1/12 of a foot times x feet equals 36 feet times 2.5 feet. And then we want to solve for x. So we could divide by 1/12 feet. The other way to do that would be to multiply by the reciprocal. That's what I end up doing even if you do division. In order to simplify that division, you end up multiplying by 12/1 feet. That takes care of that division there. I flip the bottom fraction over and I multiply. And so the 1/12 foot and the 1/12 foot canceled on the left. I divided by 1/12 feet on the right, but that's the same as multiplying by 12/1. It's the same as multiplying by the reciprocal of the denominator. So x feet, my answer in feet, will be 36 times 2.5 times 12. And that is 1,080. So 1,080 feet would be how far it would project out. Okay. Oh, and I should mention too that the units work out. My feet down here and my feet here canceled. I actually shouldn't have written it there. And so I just end up with feet on that side. And so that makes sense. That's what we wanted, was just feet. So that's another way to kind of check and make sure you're doing things correctly, is to look at your units. Sometimes that helps. So let me know if you have questions from there. I hope that helped.